Have you ever wondered what happens to Earth's upper atmosphere during a solar eclipse? Well, NASA certainly has, and they're about to embark on an intriguing experiment to find out. As part of the atmospheric perturbations around Eclipse Path mission, or APEP for short, NASA plans to launch not one, not two, but 3 rockets into the moon's shadow during the total solar eclipse on April 8, 2024. So, what's the big deal about firing rockets at a solar eclipse? The idea here is to better understand what happens to Earth's upper atmosphere, specifically the ionosphere, when the sun is temporarily dimmed. This electrified region, which sits between 55 to 310 miles above the ground, plays a crucial role in reflecting and refracting our radio signals. It's a dynamic and somewhat unpredictable region, subject to disturbances that can potentially interfere with our communications. Now, you might be thinking, why don't we just use satellites to study these changes? Well, it's not that simple. Satellites may not always be in the right place or time to cross the eclipse path, but with the exact date and times of the total solar eclipse known, NASA can launch targeted sounding rockets to study the effects of the eclipse at precisely the right time and at all altitudes of the ionosphere. The plan is to launch these rockets from NASA's Wallops flight facility in Virginia. They will take off at 3 pivotal moments: 45 minutes before, during, and 45 minutes after the peak local eclipse. As the eclipse shadow races through the atmosphere, it creates a rapid, localized sunset that triggers atmospheric waves and disturbances. By gathering data on these disturbances, scientists hope to validate and improve current models that help predict potential communication disruptions. This mission is not just about observing an awe-inspiring celestial event, it's about deepening our understanding of the ionosphere and how it behaves during these rare occurrences. So next time you gaze at a solar eclipse, remember that there's more to it than meets the eye. But what exactly is the ionosphere, and why should we care about what happens to it during an eclipse? Picture this: a layer of Earth's atmosphere that sits roughly 55 to 310 miles above the ground. This slice of our atmosphere is known as the ionosphere. It's a fascinating realm that's buzzing with energy, quite literally. The ionosphere is electrified, filled with particles that become ionized or electrically charged due to the sun's energy or solar radiation. Now, why is this electrified region so crucial? Well, the ionosphere plays a vital role in our daily lives more than you might think. It reflects and refracts radio signals, acting as a giant mirror in the sky for our communications. It also impacts satellite communications, as these signals have to pass through the ionosphere to reach us on the ground. So every time you use your GPS, make a call, or even tune into your favorite radio station, you're relying on the ionosphere. But the ionosphere isn't a static entity, it's dynamic, constantly changing in response to various factors. During the day, the sun's energy ionizes particles, causing the ionosphere to expand. But as night falls, these ionized particles relax, recombine back into neutral particles, and the ionosphere thins out. It's like a celestial dance, with the sun and earth as partners, and the ionosphere as their dance floor. Yet, there's another layer to this cosmic ballet. The ionosphere is also affected by Earth's terrestrial weather and space weather, which can stir up these particles, adding a level of unpredictability to this region. This makes it challenging to know what the ionosphere will be like at any given moment. So, during a solar eclipse, when the sun's light is temporarily dimmed, it creates an opportunity to study the short-term changes in the ionosphere. This in turn helps us understand and predict potential disturbances that could affect our communication systems. So, as you can see, the ionosphere is a critical part of our world's communication systems. So, how will NASA's rockets help us understand the ionosphere better? Well, let's dive into the specifics. 3 sounding rockets are set to play a crucial role in this mission. These aren't your average rockets. They've been previously launched and successfully recovered from the White Sands test facility in New Mexico during the October 2023 annular solar eclipse. Refurbished with new instrumentation, they are ready to be relaunched in April 2024. Now, you might be wondering, why 3 rockets? Well, each rocket has a specific launch time: 45 minutes before, during, and 45 minutes after the peak local eclipse. These intervals are not randomly chosen, they are meticulously planned to collect data on how the sun's sudden disappearance affects the ionosphere, a layer of Earth's atmosphere that is between 55 to 310 miles above the ground. When the moon acts as a cosmic curtain, blocking the sun's light, it creates disturbances in the ionosphere. These disturbances can interfere with our communications. It's like a sudden, localized sunset, triggering atmospheric waves and small-scale disturbances or perturbations. These perturbations affect different radio communication frequencies. Imagine a sea of particles in the ionosphere becoming ionized or electrically charged from the sun's energy. As night falls, these particles relax and recombine back into neutral particles. But during an eclipse, the process is rapid and abrupt, resulting in a dynamic and unpredictable ionosphere. Since satellites may not be at the right place or time to cross the eclipse path, these sounding rockets will give us a unique opportunity to study short-term changes in the ionosphere. They will be launched at the right time and at all altitudes of the ionosphere, giving us a detailed snapshot of the ionosphere's reactions. These rockets, in essence, will give us a front-row seat to the ionosphere's reactions during an eclipse. They are our eyes and ears, helping us validate and improve current models that help predict potential disturbances to our communications. So the next time you send a text or make a call, remember the crucial role these rockets play in ensuring our communication-dependent world operates smoothly. The Eclipse mission is not just about studying the ionosphere, it's about much more than that. This mission is about understanding and predicting the unpredictable, about securing the lines of communication that our modern world heavily relies on. You see, the ionosphere, with its sea of electrically charged particles, plays a vital role in reflecting and refracting radio signals. However, disturbances or perturbations in the ionosphere, like those caused by an eclipse, can interfere with these signals, affecting everything from your cell phone reception to the functioning of satellites. The data gathered from the atmospheric perturbations around Eclipse Path mission will help scientists validate and improve current models that predict these potential disturbances. By launching the sounding rockets at 3 different times during the eclipse, we're able to gather a wealth of data on these perturbations at different stages of the event. So, as we look forward to this fascinating eclipse and the APP mission, remember that what's happening up there in the sky is more than just a beautiful spectacle. It's science in action, helping us ensure our increasingly communication-dependent world operates smoothly.